Established in 1998, the AIAA Foundation Award for Excellence recognizes individuals, teams, programs, or organizations for a current noteworthy accomplishment, extraordinary lifetime contributions, or unique accomplishments that represent excellence in the aerospace community, generate inspiration for the global community, and enable the betterment of mankind. Recipients of this award have demonstrated a commitment to solving complex challenges, unraveling the mysteries of flight and space, redefining the state of the art, and pushing the very limits of human capability through innovation, ingenuity, and collaboration. Previous individual and team winners have included Norman R. Augustine, Alan R. Mullally, the Joint Strike Fighter Program, the JPL Mars Science Laboratory, the X-37B Orbital Test Vehicle Team, and General John R. Jack Daly, United States Marine Corps, retired. This year's winner is the NASA Langley Research Center in Hampton, Virginia. It is being honored for 100 years of excellence in aerospace achievements, scientific discoveries, and technological breakthroughs. The Langley Research Center is the nation's first and oldest civilian aeronautical research facility. Authorized by President Woodrow Wilson in 1915, the National Advisory Committee for Aeronautics, or the NACA, studied the problems of flight to find practical solutions. The NACA broke ground in 1917 for the Langley Memorial Aeronautical Laboratory, which in 1958 became the NASA Langley Research Center. The facility has played an integral role in shaping our nation's aerospace industry. The technology and theories pioneered and developed at the center have included variable density, full-scale, transonic, supersonic, and hypersonic wind tunnels, low-drag, streamlined engine cowlings, airfoil characterization, and laminar flow and supercritical wing designs still in use on aircraft today, the swept-back wing, the transonic area rule, winglets, and the blunt body concept that is instrumental to our nation's space and missile programs. Today's airplanes are also lighter and more fuel efficient because of NASA Langley's breakthroughs in composite materials and structures. The center also played an important role in America's space program. Langley was the first home of Project Mercury, and the Mercury 7 astronauts began their training there. Equally significant, many of the leaders of Project Mercury, and later the Gemini and Apollo programs, were Langley engineers. Until the advent of these programs, Langley was not known to many outside the aerospace community. In addition to work on aircraft and spacecraft frames, controls, and systems, research at NASA Langley has advanced flight safety in other ways. Its researchers pioneered a grooved runway surface that improved the ability of aircraft to maneuver during takeoffs and landings, helped advance the ability of aircraft to handle in-flight lightning strikes, and found ways to mitigate the effects of wind shear on aircraft. Langley researchers have also performed critical work in the study of wing vortex formation and dissipation, helping aircraft avoid loss of lift when encountering those conditions. Today, 3,400 Langley employees and contractors work side by side, a seamless team of innovators pioneering aerospace research and development, expanding horizons and opening frontiers for exploration.
The Foundation Award is about unique achievements or a legacy of inspiring aerospace contributions over time. You don't have to look hard to find both of these in the history of NASA Langley. Teamwork and collaboration are essential to our success. At NASA Langley, brilliant researchers work to solve astoundingly complex problems. But even the most gifted engineer or scientist can't get the job done alone. He or she relies on colleagues who test or help focus their ideas. They depend on the critical mission support professionals who keep the gears of the machine turning so that their research can continue. A timely example of this is the famous human computer, Katherine Johnson, whose trajectory calculations helped make America's first human space flights possible. Alan Shepard, John Glenn flew into history, but they needed Johnson's math and the computations of many like her to make it home safely. As technology, computational tools, and computer modeling continue to improve, the next 100 years will see amazing changes. Whether it be new kinds of spacecraft, flying machines like personal air vehicles, or other autonomous vehicles that can operate in the air, on the ground, and on other planets. I hope that people can connect those advances to NASA. When there are newly designed, innovative aircraft in our skies that are quieter, faster, safer, and cleaner, I hope they know it's because of NASA research. I'm confident that 100 years from now, the public will continue to be inspired, excited by NASA, our people, and the amazing things we do. We here at NASA Langley are humbled by this recognition and honored to join a truly elite group of other Foundation Award winners. The award is also special to us because of the heritage we share with AIAA. NASA Langley began 100 years ago in 1917 as our nation's first civilian aeronautical research lab and NASA's first field center. The AIAA began in 1930 as a group of science fiction writers dreaming of space flight, and over time, members of the organization have been involved with many important advancements in aerospace. A rich history of technical excellence and achievement link NASA and the AIAA. This award stands as a testament to that bond.